Okay, so today we're going to be dealing with proving triangles similar using angle. And we're going to attempt to use the online portion of one of the explorations, which we have not done yet. At least for quite a while we haven't done that. So what I need you to do is I need you to open up Clever. Okay, so you go into Clever. And once you're in Clever, I need you to go open up your textbook. Okay, now you cannot use the Readium textbook right now. You have to open up the textbook. Okay, and once you're in the textbook, you need to get to section 8.2, please. Okay, so I want you to do that right now. So I think it's Student Dynamic eBook app is where you would like to be. Okay, and once you open that up, computer is being speedy. And close some of these tabs open or close here. Okay. That way, there we go. All right, so mine's still opening. I don't know if yours is taking that. Everyone get yours open? Still loading?
Mine finally loaded.
All right. And I need to select the cool textbook. Oh, sorry. I should have selected geometry. You guys didn't even catch it. Carson did. I said the cool textbook. Whatever. All right, select geometry. Section 8.2.
Wouldn't like the square one be more sensible for geometry?
Sure.
Like the whole, because like geometry is more like complex, it triggers a different.
Yes, shapes.
Sure. All right, once you're in here, if you go, you guys should be able to come over and is there a table of contents on here?
Yeah, it says contents.
My book's taking forever to load.
It should be read about
It's at the very top left.
Yeah. Well, I think it has to load my book first. All right. So here we go. Table of contents. Go down to 8. You guys obviously know this because you're there and I am not. 8.2. Okay. And once we're there, see exploration number 1. That's the one we're doing. If you look over and click on that little circular alien-looking thing, click on that. Good. Yeah, you know, if you like connect all, if you watch enough sci-fi movies, there's always something where you connect dots and then like some realm opens to a new world. It's crazy. Okay? If that happens here, we've got problems. All right, and it should bring you to this, correct? Oh, it's loading. Okay, mine's already loaded because I did that a long time ago. All right. GeoGebra. What you're going to be doing is you're going to use your student journal today. Okay, if you look at your student journal, on page 226. Okay. So on your student journal, it says 106 and 31, so figure out how to change this angle measure that they gave you to 106 rather than 107. Ah, you're going to figure it out? Come on. Anyone figure it out? Yeah? How'd you do it? This? Okay. No? Okay. Can anyone just grab this C? Oh yeah. Just grab C and move it around until you get 1 and 6. You can grab F also. 106 and 31. Can't do it? Oh.
Yay, I did it.
Oh. Woohoo! You can do it. All right. So, on that, you're going to go ahead and complete this exploration. It says construct ABC and DEF. You have 106.31. And make sure they're not congruent. And then find the third angle measure for the side lengths of each triangle. Okay? For column 1. So right now you're just working through column 1. Okay? All right. Off you go. Do your best on it. All right, there are some of you that are having a hard time figuring out the side lengths. So that's what it's asking for on this right here. After you find angle C and angle F, some of you just calculated that, but then AB, anyone figure out how to find AB? How do you do it, Lexus? Okay, click on that. Oh. Okay. So if I want AB, I click on A, B. Boom. That's awesome. And then just so you know, you can click on this little guy here and move it around. And if you click on this little guy here, oops, you can grab that and move it up there. Just so it's out of your way. It's totally radical. All right. Hey, and now you can fill in that AB is 4. Okay? Woohoo! Once you find all those side links out, you calculate, get all these guys, you fill it in. And you for those of you that didn't want to do the angle measure, by the way, just really quick, one thing you could have done is you could have came up here and selected this. And if you go from B to C to A, it'll give you that angle measure. Okay, now just note you have to select them clockwise. If you go counterclockwise, so like D to F to E, it gives you the exterior part. Yeah, you could, but it want to let me undo.
Yeah. It like froze, and so all I did was just refresh the page and it all went away.
All went away?
Yep.
All right. Well, if I did that the wrong order, I could then just select this way and get the. Yeah, mine's like glitching crazy.
Yeah, that's
right now.
pretty glitchy. Yeah.
All right. I'm just gonna refresh it.
Yeah.
Good call. Okay. So there undid. All right. But after you're done there, if you'd like to restart and then do the next one. The next exploration says to calculate these two triangles. So you've got to form 88 and 42. Calculate this row, and then 40 and 65, calculate that row. And then 4 and 5 and 6, that's up to you. You make your own measurements up. Okay? All right, I want you to go ahead and work on those triangles. Make up your own measurements on 4, 5, 6. Get as much as you can done in the next 5 minutes or so. A little glitcherific. Pretty cool term, right? Glitcherific.
What program is it where you can record what's on your screen?
Live me.
The one that I'm doing,
Yeah.
I'm using right now is Screencast-O-Matic.
How do you get it?
Okay, so I want you to pause where you're at. These are the measurements I have. Okay, now that is with everything filled in. Obviously, I did not do that right now while you guys were working on it. However, these over here will vary. It depends if you actually completed these and came up with other angle measures. But these right here, those should match up with what you have. I hope. No. Just 43? Okay, let's go. How about we go with row 1 first? Or column 1. Good?
No.
Uh-oh. Which one's wrong?
My AB's 4.
Your
Mine
AB's
too.
4. All right.
Yeah, same with mine.
That is true.
Oh, that
That one's 4. What's this one?
It's
8.4.
And this one?
5.64.
This is ridiculous.
The next one's 11.
All right, hold on.
8.4.
I just want it to be the first one.
We're not going to do this. Hold on. Let's go with this. All right. So you guys help me out here. This is 43.
Yeah.
Hey, I got that one right. You know what? I probably used the 107. That was probably the problem. 5.64. What's this one?
11.4.
No, even if you use the 107, it's still 4. I did that too, and then
11. This is what? 11? How about this one?
3.0. Oh, okay.
And
My spotlight.
all right. Okay. Well, how about column 2?
50. 50.
Okay.
4. 8.4. 5.22. Carson.
9.6.
3.44.
4.
Oh, it is a 9. That one. I thought that was a 4 that I
And?
wrote. But it's
Okay. And how about this one? This one's 2.66.
Yeah.
This one?
5.9.
3.9.
5.9.
5.9.
5.9.
Okay. And the last two.
3.75.
Okay. Hey, well, thank you. Obviously, that page is no good. Let's go ahead and take a look at the rest of the exploration. You've already completed parts C and D. Okay. Well, you can answer part C. You actually need to answer part C. We're not going to necessarily do that one if you haven't got there yet, but I want you to make a conjecture. So answer question C. Okay. Make a conjecture on part F there. Okay. Hey, are the two triangles similar?
No, when you say
Yes. Why are they similar? Okay. So they do have the same angles, right? They have the same angle measures. We know the 106 and 31 are the same. 43 and 43 are obviously the same. Are the sides proportional? So is AB proportional to DE, which is proportional to BC to EF? So in other words, does this fraction right here formed that proportion, AB to DE, is that the same as that to that? Which would be BC to EF, which would be the same as that to that. Oops, sorry. So are these fractions the same? How could we figure that out? I mean, obviously they don't look the same. How could you figure it out? Yeah, divide them. No? They are? What do they all become? Hey. They're not the same? Really close? So what did you get? They're about a tenth off. They're really, really, really close. Okay. So they're very close. Why would they be like really close but not maybe exact? Think back to your program there when you're actually measuring them. Yeah.
It like maybe doesn't go. It only goes to 2 decimal places over.
Yeah, the computer's rounding it off. Okay, it rounded to the nearest tenth, right? Or the nearest hundredth on some of these. Okay, it only went 2 decimal places over. So yours might only be accurate out to 1 or 2 decimal places. Okay? So yes, they are similar because the sides are proportional and the angles are congruent. How about letter F? Make a conjecture about any two triangles with two pairs of congruent corresponding angles. So you guys go ahead and figure out what you can conclude from that there. Sam? Okay, so what could you conclude about the triangles then? Not that they're congruent. They're similar. Yeah, so the sides are proportional. So any two triangles with two pairs of congruent corresponding angles give you congruent or similar triangles. Okay? Two triangles with two pairs of congruent corresponding angles are similar. Okay? All right. Hey, I want you to go ahead and try number 2 and 3 there on the bottom. Give them a go. All right, Carlos got number 2 for us. Go for it, Carlo. What can you conclude about two triangles when you know two pairs of corresponding angles are congruent?
That they are similar and proportional.
That they are similar, which automatically means they are proportional. So if we find RS, what's RS in this one?
4.
Yeah, it's going to be 4. The triangles are similar, right? So you have to have the same similarity ratio. Compare the sides. The sides are proportional. Okay? Similarity ratio is 3 to 4. All right. So really, guys, if you take a look at page 228 of your student journal, really the big concept for today is the angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So as long as you know in a triangle that they have two pairs of congruent angles, the triangles are automatically similar. Okay? Now, as we talked about today in our warm-up, that is not true in a quadrilateral, right? Think of a rectangle versus a square. Okay? But it is true with a triangle. Okay. Any questions there? All right. Your assignment today, there's 2 parts to it. There's the extra practice, which is page 229 of your student journal. And page 230 of your student journal. And I also have a puzzle time I'll give you.